Well, it doesn't look like we have any attendees yet, but for those joining us on YouTube, thank you so much. And this is the Fairbanks Museum Planetarium, our Tonight Skies with Bobby Farlice-Rubio. And yeah, well, we might not see much tonight, but go ahead and take it away with what is a possibility.
All right, well, welcome everyone. Those of you who may be watching later or watching now. Tonight, I wanted to continue talking about some of the stars that are rising in the east that are sort of the harbingers of the summer to come. We talked about Lyra, the constellation with that bright star Vega, and I mentioned the summer triangle, and I talked a little bit about the other constellations that are part of that. But I also mentioned that when you're looking in the direction of Vega and Deneb, the two brightest stars of the summer triangle, you're looking in the direction of where we know there are thousands of planets. So I'm going to go into Stellarium first, but I also want to pay a little homage to the very famous Kepler mission that gave us so much data about finding exoplanets, and the new and ongoing TESS mission that is now already discovering planets. Even though it's a process that takes time, TESS has already found over 40 exoplanets, and it's a new robot that's got many years of service ahead of it. So let's get going by heading into Stellarium first. And if you haven't downloaded Stellarium, that's available for free. It's stellarium.org. And this is free software that works on any kind of computer, Mac, Windows, or even Linux. And I highly recommend it. You can use it to practice the night sky. Hold on a second. I'm trying to load the universe onto my computer. It's taking a minute, but here we go. All right, so Stellarium. Right now, of course, the seasonal settings make it look like it's far into the summer, but that's just because it's using a picture from a place in France, a beautiful location. But I don't want to go too fast with our sunset. But if you hit the L key on your keyboard, you can see the sun setting. I can fast forward time, and tonight's sunset is at 7:51. Of course, that depends based on how many mountains or forests you have around your house. But by 8 o'clock, the sun will be out of sight for everyone around here, and that's when the sky will begin to darken. Here it's about 7:30 in Stellarium. I can hit the speed button one more time and speed up a little bit. And you will, of course, see that before it's fully dark tonight, just like we've been talking about for the last several weeks, the planet Venus will be the first thing that you see as the twilight fades. And as I've mentioned before, this is your last chance to say goodbye to the winter constellation Orion and Taurus. As you will see the night get darker, they're going to be barely visible above the horizon, and their month is up. By the beginning of May, you really won't see them at all. There's the outline of Orion, the great hunter, and there's Aldebaran, the brightest star of Taurus, the bull. You might remember the Seven Sisters cluster. Well, that's going to be tricky to see at this time of year, but it will be right above the horizon once it starts to get dark. So unless you have a really clear level horizon of the west, you probably won't see many of these things. But look at what else you'll get to see. Now we're looking at around 9 o'clock. After the twilight has faded, it's about 9:17 here in Stellarium, and Venus is still very bright. And Gemini, the twins that you may remember from previous episodes of this broadcast, they're still out, even though they're a winter constellation. Because they're so high in the sky, they stay in the sky longer than Orion and Taurus. And also, remember from our talk of the ecliptic or the zodiac, the sun will go in front of Gemini, and that happens during the end of June and into the beginning of July. So that gives you an idea as to when you will totally not be able to see them. But before that time comes, they will fade away, just like Orion is now. And the Gemini constellation is where the sun is during the summer solstice. So it's always good to remember that Gemini is high in the sky, just like the sun is during the summertime. And we talked about Cancer, the pitiful little crab constellation, and Leo. And we've also talked about Virgo. And you can see me working my way down the ecliptic line towards the stuff that has not quite risen. But the summer triangle and Vega are zodiac systems. So they're not zodiac systems. So they're not a member, the Lyra constellation that we talked about last time is not a member of the zodiac. It's in a different location in the sky. But check it out. It's only 9:20. And now not only can you see Vega, you can see the entire constellation of Lyra in that direction. But let's zoom in a little bit on that part of the sky. So if you remember last week at 9 o'clock, it was just early, just dark enough to see Vega rising above the horizon. So look at what a week does. I mean, now the star is way higher in the sky at the same time in the evening. And that's how you can imagine that eventually, as we get close to summer, Vega will be directly overhead by the time it gets dark. And that's where the summer triangle gets its name. But I want to focus a little more on another member of that triangle, the one over here called Deneb. We're only seeing 2 of the 3. So to see the entire triangle, we'd have to stay up a little bit later. Let me do that for you here. So now we're getting close to 9:30. And you'd have to be a night owl. A person like me who likes to stay up late to be able to see the entire summer triangle. So let's go a little faster and make that happen. There's Altair. So Vega, from the diving eagle shape, Alvika, that ancient Arab astronomer saw in this. Deneb, which means tail in Arabic. And Altair means the eagle. And a little side note for those of you who are fans of video games, you may know that there is a character named Altair from the original Assassin's Creed game, and his symbol is the eagle, and he's always making that screeching noise when he jumps off of the rooftops of buildings. Well, if you're wondering where that word comes from, Altair, it's Arabic, and now there's your connection to video games. So you kids watching can tell your parents that playing Assassin's Creed is educational. However, let's talk more about the other star over here, Deneb, because Deneb is the brightest star of Cygnus the Swan. So I want to make sure we don't get confusing here. It's the second brightest star of the summer triangle, but the summer triangle is not a constellation. It's one of those things with the unfortunate word named asterism. It's just a formation of stars that people use in folk tales and cultural accounts and just everyday conversation, like the Big Dipper. That's not an official constellation. That's an asterism. And so is the summer triangle. But the summer triangle's brightest star is Vega, rising first. Second to rise would be Deneb, and you can see by their arrangement above the horizon that the third to rise, the last, will be Altair. But let's focus on Deneb, the one that means the tail, because that's the tail of Cygnus the Swan. And this is the tail, but the head is a star over here called Alberio. And if you connect that with the stars in between Deneb and Alberio, you can see the long swan's neck. And here is a bright star in the middle of its body called Satyr. And then down here, a star called Al-Jannah and a star called Fawaris make this wing of the bird. And if you go up from there, Fawaris 2, which I'm a little confused about that. I got to find out what the story on that is. But I wonder what that word means in Arabic. I wouldn't be surprised if it refers to something about a wing. But you can see there's a few number of stars, and they all have the Fawaris name. They represent this other wing of the bird. So if I connect the dots, you can see how you can easily make a big swooping or soaring bird out of these stars, like a swan, like a goose, any long-necked bird, like a crane. And there's a lot of cool stories about this bird from different cultures in the world, including some stories that I've heard from China and Japan that refer to this bird as being a deity that helps two lovers meet. So maybe we'll get into that on another day, or when we continue talking about the summer triangle. Maybe I'll save that for later, because there's a special holiday in China that is specifically about this constellation and those lovers reuniting. So a lot of cultures around the world have seen a similar shape in these stars, a bird flying down the length of the Milky Way. So like the summer triangle marks the Milky Way, you could say that the bird of Cygnus is flying down its length. That's an easy way to help you remember how to see it. And of course I can use, Stellarium's nice little illustration here of a swan flying down the Milky Way. But now I want to talk about something a little different. I mentioned last time we were going to talk about the Kepler Space Telescope. The Kepler Space Telescope is now decommissioned. It's still out there in space, but it doesn't work anymore. But there's a lot of cool stories about how when parts of it broke, they were able to salvage it and fix it and make it, keep working. So they were able to extend its mission a lot farther than it was meant to work. But the Kepler Space Telescope is a telescope designed to look for exoplanets. And the way we find those exoplanets, maybe I need to stop using Stellarium for a moment. I'm going to have to do an illustration. Is imagine that my big bright face in your camera view is a star, and imagine that my finger is a planet going in front of it. Now, the planet might be too small for any telescope to see relative to the size of the star. I'm the big sun face. Well, anytime a planet goes in front of a star, if it goes in front, we call that a transit. And if it does that, it causes a slight dimming of the light. Just like, if my face were actually lit up like a jack-o'-lantern, this would block some of the light from reaching you. And even if you couldn't see the planet, but you had a sophisticated way of measuring light, you would actually be able to see that the light had dimmed slightly as the silhouette of the transiting planet goes in front. And imagine if you're a scientist and you see that in your data, you can't say that's a planet because you've only seen it happen one time. So the Kepler scientists had to watch 3 transits continuously, consecutively, to be sure that they were actually watching a planet instead of just some random rock flying through space that happened to block the view. So these transits is how Kepler saw the exoplanets, and the range, the area that Kepler looked into was not much bigger than, I think, about 9 full moons, if you made like a grid of 9 full moons. And I'm going to show you what the grid looked like, because the area where Kepler was studying the exoplanets is exactly on the wing of Cygnus the Swan. And I've even used the same picture that Stellarium provided. So hold on a second. Let me pull up that image here. I hope you folks can see that clearly. So on the left-hand side of the picture, you have the actual frames of Kepler's data. You can see that it had, divided up that part of the sky into little sections, little rectangles. And in those rectangles, the stars that Kepler studied numbered roughly 140,000. So 140,000 stars in those rectangles. Kepler, a robot that doesn't need to go to the bathroom and doesn't need to take a break, staring at them continuously for several years, measuring each individual star's light and noticing which ones were dimming with a regular period. And if you look on the right-hand side of the picture, the area where Kepler was looking for all of its planets is on the wing of Cygnus the Swan, right around those Polaris stars that we talked about, and a little bit of the Lyra constellation that we talked about last time too. So you can stare at this part of the summer triangle and just think, we know that there's worlds in that direction. And Kepler was amazingly successful. They thought it might find some planets. Maybe if they got lucky, they would find hundreds of planets. But here is the thousands of planets that Kepler discovered. If you look at this funny chart with all these dots, the ones near the top are about the size of Jupiter. See the guide on the right? And the ones near the bottom, that line near the bottom represents planets the size of Earth. And then if you go left to right, you can see their orbital periods. There are planets that take less than a day to go around their stars. So those are easy to find because we can see, 3 transits in a day, maybe. But other planets, if you can go to the right-hand side of the chart, might take over 1,000 days to make a transit. So that means that Kepler would have had to stare for 3,000 days, 10 years, to be able to discover them. And it turns out that Kepler did actually last for almost 10 years. You can see there's a yellow dot close to the 1,000 line, because that was one of the last observations that was able to confirm before the device stopped working. So let's see if I got the picture here that NASA provided by the numbers, if you want to know all the things that Kepler accomplished. Let's see if oops, sorry. My field of view is missing some of the data. This is one of the problems with Zoom. I can't see the screen as well as you folks can, I think. Oh, there, I figured out how to move my thing out of the way. All right, so 9.6 years in space. 2 missions because they had the K2. That's after it broke and they figured out a way to fix it. 530,000. Oh, I'm sorry. I underestimated. I thought I said 140,000. Forgive me. 530,000 stars observed. 2,662 planets confirmed. It actually witnessed 61 supernovae. It only used 3 gallons of fuel. That's interesting. I wish my car was that efficient. It's 678 gigabytes of data collected, almost 3,000 scientific papers written just on what Kepler saw. And I know one of them by famous astronomer Tabitha Boyajian is probably the most famous, called WTF. It means where's the flux? And that is a study based on the fact that Kepler saw one place where there was really weird observations, and Tabitha Boyajian thought they were so strange she actually went to 2 other telescopes in Hawaii and in California to back up Kepler's observations just to make sure it wasn't hallucinating, this telescope. And it looked like there was something complex in front of a star, and she never mentioned the word, but when the news reported her discoveries, everybody said she found aliens. And you could look up Tabby's star and Tabitha Boyajian if you want to find out about that. But that is one of those nearly 3,000 scientific papers that were published because of Kepler's work. And if you look at the picture on the right, just to help you understand, Kepler is orbiting the sun, but it's not near the Earth. It's really far away from us. It's farther from us than the sun. It's actually in an orbit that allows it to stay away from the Earth and, kind of view that part of the sky without having to worry about day and night cycles or weather and all that. So this is one of the most incredible missions that NASA has launched. Oops, let's see if I can get out of there, because it way overperformed from what we expected it to do. But the one thing I want to leave you with is you don't have to have that big fancy telescope to just wonder. When you look at the summer triangle, you see that we know there's so many worlds in that direction. And then I have to tell you that Kepler, even though it stopped working, it's been replaced by an even more powerful satellite called TESS. And my last thing I'm going to show you here is the website. Oops, I think I've got the wrong tab open. Hold on. Here, I was using speed test to check my internet connection. But this is a website that's NASA's Exoplanet Archive. This combines everything that we know about all the exoplanets, regardless of which mission discovered them. But Kepler has found the majority of these, 4,152 confirmed planets. And look at this. Oh, sorry. TESS. Even though it just got going about a year and a half ago, it's already seen 45. And it might not sound like a big number, but remember that it takes multiple transits. So if it's looking at planets that take a year to go around their stars, similar to the Earth, it's going to take at least 3 years for TESS to see them. And TESS hasn't been out there long enough for that. But look at that. The project candidates, TESS has over 1,800 that it's watching that could be planets based on further data if it has another transit. And the thing about TESS that's different from Kepler is that TESS looks in all directions. So instead of Kepler staring at the wings of the swan, TESS is looking over here, looking over there, looking in every direction until it eventually maps the entire universe as visible from its location. And it's in space, so just like Kepler, it doesn't have to worry about day and night cycles. There's a picture of TESS that I think just, oh no, that's Korot, a different satellite. But anyway, let me not confuse you too much. I think we've done enough for today. But now, let's hope the weather clears and you can see this. But if you want to go on the Exoplanet Archive, you can do that, and you can check out all those planets. I'm not going to be able to summarize them all in the time we have left, but there are many. There are dozens of planets that are the same relative size as the Earth and are in what we would call in exoplanet science the Goldilocks zone. Not too hot next to a star that would burn it, not too cold, but somewhere that's just right. And that just right zone is the place where we think life would be most likely, because water would be a liquid. But I guess we're kind of biased, assuming that life needs temperatures like we do. Let's remember that for all we know, there might be no life out there except for us, or there could be life in many different kinds of environments, and maybe some life likes it hot, maybe some life likes it cold. So I'm not going to go into all that. That's another subject, but that's one of my favorite subjects to teach because I remember very well when I was a teenager in high school and they discovered the first exoplanet, and now the list is over 4,000. So this is a very new branch of astronomy. It's, younger than me, and it's not been around for a long time. And it's the one that is almost certainly going to grow the fastest as we go from 4,000 to maybe 40,000. And maybe by the time, I'm putting in my dentures, we're going to talk about 1 million exoplanets or more, who knows? So anyway, sorry about the weather. I can't control that, but we're going to have plenty of chances to see the stars, although I know that it might be cloudy for the next couple of nights. I think next week is supposed to be much clearer weather. So I hope you get out there as it gets warmer. Now you hopefully will spend more time outside and not worry about freezing. So I hope you all keep looking up. And Leela, thank you so much for hosting this. I don't think we had any questions coming in, did we?
No, I didn't see any, but thank you so much for all your information and that and an activity to do a little exoplanet hunting on their own. I think that's a great thing to try out, especially when it's raining.
Find your own dream vacation world, find
that's right. Well, thank you so much. This was great. And again, this will happen next Tuesday at 2:30. So we'll see you again then.
Thank you. And thank you, Leela. Take care, everyone. Stay well.
You too. Take care. Bye.